So now you have to find the zeros of the profit equation, and it tells you right here you've got to use the quadratic formula. So here's the equation, minus x squared plus 100x minus 2000. Okay. In this form, a is minus 1, b is 100, we already knew that, and c is minus 2000. So you can put all that into the quadratic formula, which you can look up or write it here for you. Minus b over 2a, which you already know is 50, plus or minus, take the square root of b squared, which would be 100 squared, minus 4 times a, which is a negative 1, times 2000. So and this is over 2 times minus 1. This was 50, we already knew that. Okay. You've got to square the 100, but now look, you have this is negative, this is negative. That means this last term, which is going to be 8,000, gets added in. See the two negative signs here? These are all multiplications. Okay. And then you take the square root, divide by 2, and there you get your answer. You'll have two answers. And that will give you the zeros of the profit equation. Now you need to compute the profit the owner makes when he sells 150 items. So here was your profit, minus x squared, what was the rest of it? Plus 100x minus 2000. That means you substitute 150 for all the x's and you square it. And here again we have, oops, it's right here. Here again we have the problem of the negative sign. Okay. In this case, the only thing that gets squared is the x, the 150. The negative sign remains. So you will have a negative term here, a negative term here. This one's positive. You find that this is much less than 0. So when he sells 150 items, he's really in the hole. It didn't help him to sell 150 items. The next piece of this problem is to find the zeros of this particular revenue function. So it's given to you right here. Now, this is something to recognize. Do you see that you've got an x squared and an x term? Factor out an x. This is really easy. Okay, I factored out the x, and I'm left with minus, I'll leave it in here more, 0.4x plus 108. What are the zeros? Well, you really have your two factors here. One from that term is x equals 0. To find the other 0, set that equal to 0. Minus 0.5x plus 108 equals 0, and from that you'll find x2. So this is like the problem with the orange grove. It was easy to factor. In fact, you'll recognize this looks pretty similar to the orange grove equation. In that case, the x was out in front, so that gave you the solution x equals 0. You have to solve this to find the other one. Now, using symmetry, find the x value of the vertex, which is h. Okay? You take those two values, here's your x1, and what you get from up here for the x2, take them together, divide by 2, that will give you h. Take the h back in the original equation, there you've got k. Now, what is the y-axis intercept of the cost equation? That sounds kind of hard until you remember that at the y-axis intercept x equals 0. So go to your cost equation, put zeros for all the x's, and you find that c is 2000. Everything else goes to 0. Now what's the y-intercept of the profit equation? Profit is revenue minus cost. Okay? What's revenue? When you don't sell anything, when x is 0, your revenue is 0 minus 2000. So this looks similar to what we had before. Here's your money axis. Here's your x-axis. The revenue is 0. Here's your 2000 for where the costs start, but your profit starts at minus 2000. With this information, sketch revenue, cost, and profit on the same graph, and I do distribute that graph with the homework, but I want you to go ahead and mark it up and identify the curves and get an understanding. I'm not going to say much about this problem. It's not really an extra credit problem, but generally people who are pretty good at math will get this one. Take the x squared term out of the cost equation, and you'll end up with a quadratic for the revenue equation, and then you'll end up with a new cost equation. take your profit and go R minus C, find your new quadratic formula again for profit, and from that find the vertex. And that's what you do there. By eliminating the x squared term, you eliminate those inefficient workers. This problem has a big setup. Part of the setup that I want you to get familiar with is that the equation for a projectile. And this is how I write the equation for projectile. Projectile is anything that gets shot or dropped or whatever. And all we consider in algebra is the vertical, how it's going up and down. And so it's going straight up and down in the air. Right? You know that it would make a curve like that in space, but you have to get to trig in order to solve that problem. Okay? So all we're going to say is this thing's going to go up in the air, take a certain amount of time to get to its peak, and turn around and come back down. Here are all the terms. Y is how high it is, how high it goes in the air. Y0 is how high it is when you shoot it off. This is your launch height. Y0. When t is 0, you assume you shoot the arrow at t equals 0. So at time 0, where are you? If you climb up in a blind, then Y0 is the height of that. V0, that's the velocity you give to this arrow, or whatever it is, as soon as you shoot it off. It's multiplied by t. This last term has to do with acceleration due to gravity, and you don't learn about that term until you take calculus. Then you learn more about that term. So trig and calculus, you'll see this equation over and over again. Get familiar with the various pieces of it, but we're only using it for algebra here. So what we're going to do in this case, in the next graph, we're going to shoot this arrow off from the ground. So this term is gone. It's going to be 0. And we'll have a simpler equation, and I'll give you some numbers. So here's the equation that you'll be working with. Y equals, okay, the velocity times time minus 16 t squared. Okay. So I'm going to give you, what did I say on here? They're all shot from the ground. Alright, I'm going to give you that initial velocity, this value right here. And from that, you set y equal to 0, and you compute the 2 times this thing is on the ground. Okay, so let's say I shoot it off with, okay, 160 is my initial velocity. So you'll end up with different values right in here. This number is going to change, but the technique won't change. Here's what you do. If you want to solve this problem, you see that you've got t's here, and you can factor them out. So this becomes 0 equals, factor out one of the t's, equals 160, in this case minus 16t. Now you have it factored. You set each factor to 0. Okay, when this one is 0, t1 is your first root. In other words, at time 0, the arrow's on the ground because that's where you shot it from. Now you take this next term and you set that equal to 0. 160 minus 16t is equal to 0. Rearrange this until you find out what t is. That's the second time it's on the ground. Now that you have those 2 times, change color here a little bit, you have this one, these 2 times that it's on the ground, and you want to find its maximum height. Well, that maximum height is the peak of the vertex. This is a quadratic. So you find h, this is the time at which you're at the maximum height, okay, and that will be the average. Then you take this value, put it back in your original equation, and that will give you the k. So in the homework will be this worked out example. So let's just look at it here. Let's say that your initial velocity was 88. You have a 0 here because you're shooting, your launch height is 0. So this is your equation. Y equals 88t minus 16t squared. Put your velocity here, right there, and there you go. Okay, now to find the zeros, set y equal to 0. When I set y equal to 0, I have this equation. This equation is easy to factor. Factor out a t. Here's that t that gets factored out, and then you have another term that's easy to solve. To find the zeros, set the t equal to 0 is one solution right there. Now look at the 88 minus 16t and make that solve that for 0. So we're talking about here is you say 88 minus 16t is equal to 0. Solving for t, I have minus 16t equals negative 88. Now I divide by the negative 16 and I find that t is 88 over 16, which in this case is 5.5 seconds. Okay, so now you have these two numbers. You know that the arrow is on the ground at t equals 0, and you know the second time that it's on the ground, 5.5 seconds. So where is it at its peak? Halfway between those numbers. So here's your h. You average those two numbers and you get 2.75 seconds. How high did it go? You take this 2.75, you put it back in the original equation. You see here it's right here. And over here you have to square it, and you find that it went 121 feet in the air. It got to that height in 2.75 seconds, and it came back and hit the ground in 5.5 seconds after it was shot. So with that information you can fill in the chart. So that's what's done for this first case. Here was the equation. Remember, you factored it out, set each factor to 0 to find these two numbers. You average these two numbers to find the h. From the h you put the h back in this equation, right here in that equation, and you get the 121. So you go down here, in this case, I got the highlighter here. Here's a 135. It's going to take the place of the 88 here. That will give you a new equation. Again, you factor out the t, find two values of time that the arrow's on the ground, average those two values, get the h for this column, put the h back in the original equation, and get the height, the maximum height of the arrow. And so you have all those different times, velocities. The 88's done, 135 to 206. Here's this compound crossbow, 242, and then just trying to fling it by hand, and that's, we'll say, 29 feet per second. Obviously that's somebody who can't throw very well. Then you can graph all of those, and they will look something like this. So there's some graph paper. Whoa, that was pretty bad. Okay, now let's try some different colors here. So you'd have the time that it's on the ground. Here's the other time. Okay, for the case that we had. Halfway in between, it's going to be at its peak, and here would be the value of the peak, 121 in this case. That was for the first one, and it goes up like that, turns around and comes down, and that's about the worst parabola probably anybody's ever drawn. Okay, the next one, let's say, might come in out here, so it stays in the air longer and probably goes higher. This would be halfway between the two, so you'll have another curve, and so you'll have a whole bunch of curves that look like this. Of course, the little 29 will come in like that. So you take all those numbers and graph it, and all that procedure is worked out. The first one is the example for you to use.